So this will be the last video for the course, and so this video covers sections 5.4, 5.5, and 6.1. So in regards to section 5.4, it deals with indefinite intervals. And so, for example, a couple of these. So we have this, x cubed, x to the minus 2 dx. So we can tell it's an indefinite interval because there are no numbers here and here. So and again, like I mentioned before, indefinite intervals, we're going to actually end up with basically something in the form of an equation. So my basic rule then for doing this was increase the exponent by 1 and divide by the same number. So we get x to the 4th over 4, x to the minus 1 over minus 1, and then plus c. And then this, we will simplify a bit. So this will be x to the 4th over 4 minus 1 over x plus c. And with that, we're done. Right? So again, indefinite intervals, we end up with something in the form of an equation. Right? So before we had, when we talked about position function, velocity function, and then acceleration. So this was S sub t, V sub t, and then A sub t. Right? And we saw, when we talked about derivatives, that when we went this way, and we took derivatives, we got, so the derivative of the position function was a velocity, derivative of the velocity function was acceleration. Okay? But now, if we think about going in the opposite direction, and we start out with acceleration, and we end up with velocity, and then end up with position. So again, this is A sub t, this is V sub t, and this would be S sub t. Okay. So when we go this way, we do the opposite, and we integrate. Integration. Okay. So an example of that then would be given something like this. So given that the acceleration function, A sub t, is t plus 5. Well, the velocity function in V sub t would be t squared over 2 plus 5t plus c. Okay. And then my position function, x sub t, would be t squared over 2 divided by, t cubed over 2 divided by 3, 5t squared over 2, ct plus d. And then that will simplify a little bit, and we end up with t cubed over 6, 5t squared over 2, ct plus d. Okay. So we start out with acceleration, we integrate, we get velocity, we integrate that again, we get the position function. Okay. And then before, like we said, if we knew something about a value of t and a value of v, we could find out the value of our constants. And then we could do the same thing with regards to d if we had more information. So indefinite intervals then give you a equation. The next section then, section 5.5, deals with the substitution rule. now we have something that looks like this. X cubed 2 plus x to the 4th. All of that raised to the 5th power. So again, this is an indefinite interval, and again, we can tell that because there are no numbers, okay? But I want to integrate this, and so right now, what we know so far, I would have, in order to do this, I would have to expand all this out and then multiply. So you get to substitution rule, okay? So we're going to make a substitution, which will make this easier than integrate. And then, so generally in ones of this type, the u is going to be this stuff that's in the parentheses. So u is going to be 2 plus x to the 4th. Right? Du, the derivative of this, will be 4x cubed dx. So my differential gives me that. Right? Now we get to why this is called substitution. We're going to substitute. So we're going to take this out, plug this in. So we're going to integrate. We're going to have u to the 5th, okay? My du here is 4x cubed dx. The original is x cubed dx. So I figure, so now we have to go, well, we're really going to multiply this by in order to make this look like this. So we have x cubed dx over 4x cubed dx. And so you should be able to see that this simplifies to just being 1/4. And so that we can bring out front. Any constant can come out front. And we end up with now, we're going to integrate this. So we have the integral of 1/4 integral u to the 5th du. Well, that's now our basic rule. And so this will give you 1/4 u to the 6th over 6 plus c. This will become u to the 6th over 24 plus c. And then the last step is to substitute back in. So we get 2 plus x to the 4th to the 6th power over 24 plus c. And so that would be, so let's look at another one of this. So we're going to integrate x sine of x squared dx. Right? So again, we got to pick our u. So probably we want to pick our u in a way that it's going to give us that the derivative will match what we have. Okay, so if I said u is x, well then the derivative of that is just 1. That's not going to match what we have over here. But if we say u is the x squared, then the du is going to be 2x dx. So we're going to get the sine of u. And then my original is x dx. What I have here is 2x dx. So x dx over 2x dx. And so you can see again that this will just come out to be 1/2. And so we get the 1/2 out front. So now we can integrate. And so we integrate sine, we get negative cosine. So we'll get a minus 1/2 cosine u. And then the last step is to plug back in. And we end up with this. Right? And then if this was a definite interval, we just plug the numbers at this point and get an answer. Right? The last section then, section 6.1, deals with area between two curves. So, for example, we have this. My first one, okay, my goodness. Which is y equals 5x minus x squared. And then my second one is something looking like this. And this is the line y equals x. And what we want to know is, what is this area in here? Okay. So we want to find that area. So we want to integrate from this point to this point. So we need to figure out, well, what are those values where they intersect? And so we would have 5x minus x squared is going to equal x, because where they intersect, those two have to equal each other. And so we're going to solve this for x. So let's subtract x. And so we get 4x minus x squared equals 0. We can factor out an x. And then we can set each one of those equal to 0. So either x equals 0 or 4 minus x equals 0. And so we're going to integrate from 0 to 4. Okay? So we know where we're integrating from. So we're going to have that part. And then we need to set up our integral. So we're going to integrate from 0 to 4. If I look at this graph, it is my parabola curve that's enclosing the area. So that equation will go first. So it's going to be the first that equation minus the second equation. Right? So we end up with that. Right? But before we integrate, we can do any math that we can do to simplify this. We'll do next. So we can do a little bit of math here. In that we'll have the integral of 0 to 4, 4x minus x squared dx. We then integrate. So we get 4x squared over 2 minus x cubed over 3, evaluated from 0 to 4. So this will become 2x squared, or actually, 2x squared minus x cubed over 3 from 0 to 4. And then the next step is to plug in our numbers. So this will be 2 times 4 squared minus 4 cubed over 3 minus 2 times 0 squared minus 0 cubed over 3. Right? And we plug all that in, we end up at 32 over 3. Right? Right? And then one more example, and that is one that looks like this. So my first curve is going like this, and this is x equals minus 4y, and then my second curve is going like this. This one is x equals 2y minus y squared. Okay. So now, if I look at this, all right, so if I integrate this with respect to x, I'm going to have a big problem because my x-intercepts are here and here. And so if I integrate with respect to x, my area we're talking about would only be like that. So that's not going to work. It's not going to give us the entire thing. So in this case, for this one, what we have to do is we need to integrate with respect to y. If I integrate with respect to y, we're going to get the entire area. And so when we integrate with respect to y, we want my equations to be in the form of y equals. Right? And I think I do need to make one slight change, and that is I put the equations here backwards, because we'll make a difference when I do my integrals. So I want to get those right. So this will be 2y minus y squared, and then this one would have been y squared minus 4y, okay? All right. So now we need to know where are the 2 points where they intersect. So again, we take our equations and we set them equal to each other. So y squared minus 4y is going to equal 2y minus y squared. So we're going to solve this for y. So let's add y squared, subtract 2y, and subtract 2y. So we get 2y squared minus 6y equals 0. So here we can factor out a 2y. Get 2y and y minus 3. So then either 2y equals 0 or y minus 3 equals 0. So this will give us y equals 0, and then this one gives us y equals 3. Right? So we know we're going to integrate from 0 to 3. Right? So let's set up our interval. So it's going to be from 0 to 3. Right? Now my equations. Right? So again, if I look at this, it's this curve holding in the area, which is the 2y minus y squared. So this is going to be 2y minus y squared, this equation, minus the other equation, which is y squared minus 4y, and then we're going to integrate with respect to y. So again, we can do the little math first. And so we get 0 to 3, 6y minus 2y squared. Next step is integrate. So we get 6y squared over 2 minus 2y cubed over 3. Evaluate it from 0 to 3. So this will be 3y squared minus 2y cubed over 3. Evaluate it from 0 to 3. And then it's a matter of plugging in the numbers. And so we get 3 times 3 squared minus 2 times 3 cubed over 3 minus 3 times 0 squared minus 2 times 0 cubed over 3. Plug that all in, and we come out to 9. So in regards to finding the area in between two curves, we can do it either with respect to x or respect to y. And we're going to pick the one that is going to give us the entire area. And with that, that will conclude this video.